Hello, Mr. Ryan, how are you today? Okay, I guess all good. Yeah. So you know the word shuffling.
Yeah, you know snap.
Shuffling. What does it
Oh,
mean?
you know.
You know the card you're playing the poker games. Yeah, poker cards. You shuffle. You just.
Pokemon cards.
Yeah, Pokemon
But we
cards.
don't shuffle them.
Yeah, shuffle is the
They
way
don't-
to make a random permutation. It's a random permutation. Okay, random permutation. Do you still remember the permutation? Permutation. This word, yeah. This is P, yeah, and we talk about the combination as well, right? Yeah, combinations. Okay, look, let's review a little bit. Okay.
Pokemon cards.
I have 1, 2, 3, three numbers. What's the possible permutation of it? What's the possible permutation? How many ways of permutation? 6, yeah. Can you give us a few examples?
1, 2, 3.
Yeah,
Definitely.
of course, it's one of the
3, 2,
permutations.
3,
1.
2, 1. 1, 3, 2.
2, 1, 3. I said 2,
Oh,
1, 3.
sorry, I give you another 2 and 2, 3, 1, yeah? 2, 6, and one more missing.
1. No.
Come on, start with 3.
3, 1, 2.
Yeah. 6. Yeah, the way how we compute the permutation, full permutation. If there are n numbers, how many ways of doing the permutation? Remember, what's the answer? If there are n numbers, how many full permutation of n numbers? If there's n, if 3 is 6, yeah, f3 equals 6. If f4 equals what? If there are 4 numbers, how many ways of doing it?
10.
10? No, of course
8.
not. Full permutation, remember the first one we have n choice.
24.
Yeah, 24, yes. The second one we have what? N minus 1 choice. The third one we have n minus 2 until 1. And what's this? N factorial, yeah. That's the full permutation. Okay, we talk. And combination. Combination is not, the order does not matter, right? If we pick 1, 2, 3, if we pick 2 numbers out of 3, how many ways of doing that?
You can choose 1 and 2.
Yeah,
You
1
can
and
choose
2.
1 and 3.
1 and 3.
You can choose 2 and 3.
And that's it, yeah. Picking 2 numbers out of 3 is the same as picking 1 number out of 3, right? Because look, if you pick 1, 2, you left 3. You pick 1, 3, you left 2. You pick 2, 3, you left 1, right? It's the same, yeah? Alright? It corresponds to each other, yeah? Picking 2 numbers out of 3 is the same as picking 1 number out of 3, yeah? Got it? Makes sense? So, look, C and picking m numbers out of n is the same as picking n minus m numbers out of n. Okay, make sense? That's the equation. Yeah. Okay. Permutation. Okay. We talk a bit far. Okay. We're not talking about permutation and combination today. We're talking about shuffling. So shuffling. Yeah. So look at this 1, 2, 3, 1, 2, 3 shuffling. We just talked about 6 possibilities, and we want to shuffling. So each possibility needs to be a probability. Yeah, we talk about probability. Needs to be 1/6. Yeah, all right. Got it? There are 6 possibilities of 3 cards, and you want to shuffle it, and each one has to appear 1/6. This is called unbiased. What's unbiased? Unbiased. What's bias? What's bias? What's the meaning of bias?
The bass drum.
Sorry. Bias is like you have preference for some combination of for some permutation. For
I
example.
know what is bass.
Okay. Okay. Unbiased is the opposite of bias. Okay. Listen to me. Bias means that look there are 6 possibilities. Yeah. Let's do this again. Okay. 2, 1, 3, 2, 7, 1, 3, 1, 2. 3, 2, 1. So look, there are 6 possibilities, and I want to do the random shuffling. Each one has to appear roughly, ideally it will be 1/6 probability. But if I said, okay, I prefer this one more, I want to say I like this sequence, So this is bias. If your approach to shuffle has more probability of these, yeah, then it's bias. Make sense? It's bias. So we don't want a biased permutation. We want an unbiased
Why
permutation.
did you write 3, 2, 3?
3, 2, 1. Okay, good choice. Okay, so we this is shuffling, and then let's say I have a number. I have this 1, 2, 3 number. I want to shuffle it. How can we shuffle it? So one way of checking it is this, right? We can do this.
Shuffling.
Yeah. Well, okay. How do we do this? How do we do this? How do we do it? Okay. That's it. Yeah. Okay. That's enough. Okay. In order to do shuffling, we need to kind of bring in this randomness. Yeah, randomness. We talk about a random thing. Remember in the lesson of what do we call? We call this circle. Yeah. Calculate the circle. The pi r square. Yeah.
Circus.
Monte Carlo. Remember? How do we do the Monte Carlo? Yeah, this is a square, and then there's a quarter of circle. We start to throw the chocolate coins on it. Yeah, and we count how many coins are falling inside the circle. And if we divide it by the number of the coins, total coins, and we get roughly the proportion of a quarter pi, right? Right. This is Monte Carlo randomness. And when we use that randomness, we use the random function. Yeah? Random function from the random package generates a number between bigger or equal to 0 and smaller than 1, right? Yeah. And it also has other function which is called rand int. Given two numbers a, b, it will return a number random, okay, random from a to b, inclusive, okay. And similarly, we have another function called the range, right? Remember this range function. Everybody look, range function a, b, c, right? C is the step, optional. A, B. Random A, B, you will come up with the number bigger than, equal than A and smaller than B, right? Right? Or if it's rand, if you just call rand H, it's equal, it's similar, it's equivalent to range 0 A. Yeah, this is the same, yeah? So if we put a random here, random range, okay? I think it's range. So basically, you will generate an integer between this range. Yeah, range. Okay, make sense? So why are we using this random function? So we can do this. We can generate a function. So you tell me, okay? So look, if this is 1, 2, 3. If I repeat 3 times, if there are n numbers, if I repeat n times. And every time I generate a number between 0 to 3, right? 0 to 2, right? 0, 1, 2. And every time I generate this number and I swap it, yeah, right? So for example, the first time I generate this is 2, and I swap what? I will swap I will swap the I to repeat n times. Okay, so this is 0 to let's say for I in range n, look, if I repeat n times and I generate a number which is in a range n, and I will swap numbers x and numbers I. Yeah, and if I repeat this n times, so if I randomly, pick a number and I swap it. Yeah, this could be one way of doing it, but there's a problem with this. Why is that? Look, if I pick this number and I swap it with this, right? So that will become 2, 1, 3. Right? Alright? And again, I'm here, right? If I pick this number and I swap it, it will become 1, 2, 3. Again. So what's the problem? Is that one number could be swapped more than once, but ideally it should be swapped 1 time. If you repeat n times, so what's the probability of each number being swapped? Come on, that's an easy question. If it's an unbiased one, there are n numbers. I want to swap it. I want to perform this swapping. And 1 over n, right? Because if I do this n times, right? So each number needs to be probabilities of n 1 over n's, yeah, for it to be swapped, right? Make sense? Make sense? Yeah. But if there's one number which is more than this probability, then it means the other number is less than this probability. Yeah, got it? Right? Right? And what could happen if the only one number is more than n? It's being picked, and the other number is less. It's not being picked. Then it's not giving it unbiased, right? Make sense? So how do we, one way of checking if a solution is biased or unbiased is that if are the numbers, right? If we randomly swapping, if randomly perform this shuffling n factorial times, so each permutation has to appear more, one time, yeah, on average, right? Because this is probability. And if we repeat this shuffling, if we perform this swapping, random shuffling n times, so each number has to be picked for swap once, right? If it's not picked, it means it's unbiased. If it picks more than once, if it's picked more than once, it's biased. If it's picked less than once, it means it's not picked at all, it's biased as well, right? Yeah, you still with me? Do you get what I'm saying? Yeah? Eric? Yeah, okay. Okay, so what's your approach if I want to perform n times swapping? What's the approach? In order to give a unbiased swapping for each element. Any idea? So the problem of this one is that when this element is swapped, it could be swapped back using this approach, right? We don't want it to swap back. Now one way of fixing it is what? It's like, okay, I have four numbers. I put it in a hat. I randomly pick one number. I want to swap it, right? So it's swapped. So it has to be moved here. Right? This is already determined, right? Pool of the numbers. And now I want to pick another number for swapping. Which three numbers I need to pick? Okay, I already say it's three numbers. I randomly pick one number out of these, right? And I swap it. And again, I randomly pick one of the three. So the numbers when I pick already are not for pick in the future, right? The previous approach is like that. Okay, I randomly pick one numbers, I swap it, I put it back. And again, randomly pick three numbers, for one number of these four, and I'll then pick this one. So one number could be picked more than once, right? So we want to solve this problem by using these two places. Once it's picked, it moves to that, and we don't pick it again, right? That will give this unbiased shuffling, right? Got it? Make sense? Yeah. Do you think? Do you see the problem we're trying to solve? Yeah. The shuffling, it gives the random permutation, and we want to be unbiased. It means that each number, if we want do this swapping for n times, each number has to be picked exactly, yeah, once. Yeah, make sense? Okay, so then we can implement this. Yeah, we can implement this. So the implementation could be just very simple, but you have to understand the principle, which is like, you can remember this hat thing. When we pick a number, we move it here. We randomly pick one number here, we move here. We randomly pick one number here. Yeah, and then perform n times. Okay, let's define shuffling numbers. Right? Now for I in range length numbers. So we want to repeat this n times. Look, this is 1, 2, 3, 4 till n, right? So let's divide these in two halves. The left part is already shuffled. The right part is still in the head. Yeah, still in the head. Okay? Make sense? Remember the thingy I talked about here. Yeah. The left, this is the left. And this is still in the head. Okay? Still in the head. Okay? Make sense? So first of all I will generate the index. So for x would be range, right? Range, length num. So we want to generate start from the I. Start from the I. We want to swap this. We want to start from I. Pick one numbers from here to the right, right? I to the length nums. Yeah? And then what should we do? We just need to swap it. Num I. How do we swap two numbers, by the way? How do we swap two numbers, by the way? Come on, this is an easy question for you. How do we swap two numbers? If A, B, how do we swap A, B?
AB equals BA.
Wow, and if we, this is the Python way of doing it. And how about if we don't,
Deep copy.
no, how about if we want to use the third variable to do it? How do we do this?
Deep copy.
Not deep copy. What I'm saying is that we want to swap value between A and B. How do we swap it with the help of the third parameter?
What's the deep parameter?
Look, you say AB equals BA, yeah? But ideally what's behind is T equals A.
Is
A
that
equals
deep
B.
copy?
Yeah, a value to copy A.
Yeah, that's deep copy, right?
Oh, wait, yes, it's deep copy. Yeah,
I
it's
said
deep copy.
deep copy.
Yeah, but what I mean is more specific. T equals A equals B, and then what? What's the third one?
B
Equal.
is T.
Yeah, well done. Yeah. If we say B equals A, that would not work, right? Because A is already changed to B. Okay, make sense? Yeah. Okay. So this nums I nums x equals nums x nums I. Okay. Now we're swapping the index at I and x, right? Yeah. First of all, we generate index from I to the end. So here we are I here. We first of all generate index at this range. Why? Because they're still in the head. And we swap it with the I, right? Swap it with I. So we don't touch the elements before I because it's already picked. Alright? Yeah, make sense? And next time we move it because we already swap one more element. So it becomes in this. This is before I, index smaller than I, right? Index smaller than I. So that's it. Shuffling. Look, easy. Yeah? For I in range. Yeah, make sense? Make sense? Any questions so far? Okay, so one simple question. What's the probability of swapping n elements? What's the random shuffling probability of each permutation? If there are n items, how many ways of full permutation of it? I just said at the beginning, if there are n items, 3 items, how many ways of doing it?
6.
Okay, so n items, how many ways of doing it?
And factorial.
N factorial. Okay. There are n factorial. Each one has if it's unbiased, what's the probability of each permutation? If it's unbiased, what's the permutation?
1 over n.
Yeah? Easy, yeah? That's simple maths, right? Simple maths. Do you understand this part? So we are separating this array into two halves. One is this bit. The right hand side is still in the head. It's the numbers we are not picking yet. So every time we generate a number at this range, we want to pick a number at this range and we swap it with the current one. And then we move it so this number is determined. Okay. Why we want to do it? Because each number is only swapped once. Yeah? Once it's swapped, it becomes on the left side. Look at me. It becomes on the left side. So can we say this? If a number is swapped only once, and if we perform n, because we are performing n times, right? There are n numbers. We're performing n times. Each number is swapped only once. So what does it mean? Every number gets the equal probability of being each location, right? right? So there are n number and n slots. Okay, the n slots. Listen carefully. Okay, there are n slots, n numbers 1 to n. Each number is being swapped once, and if we swap n times, right? So it means what? It means that each slot, each number at each slot, right, is what? It has this equal probability, right? All right. So it's unbiased. It's unbiased. We want the unbiased. Each number should be on each slot, right? We don't want a biased one. We don't want to say okay we want 1 in this slot because we just like it. We can't say that, right? It needs to be equally distributed, right? If I say okay, they are more likely this chance of 1 in first location is 50%. On all others is 50%. That's bad. That's bad shuffling. When you play the random shuffling card, do you want the top of the card to be more likely, like some, I don't know, yeah, your favorite, right? Then that's bad, right? Because people think, okay, people could guess, all right? Do you see what I'm saying? If it's randomly shuffling, it means that the top of the card could be anything. If there are n cards, the top of the first position of the sequence, random shuffling sequence, could be anything, right? So we can't guess because it could.
You know.
Huh?
You know the game. You know.
Yeah. So yeah, if people can guess the random shuffling of the more likely, then there's no point of shuffling, yeah. Right? The point of shuffling is make it non-guessable, right? Yeah. So it could be anything, right? Because each permutation is unbiased, is equally distributed. So you can't make a guess. There's no more likely or less likely. Okay? Okay, so I feel like I talk a lot today, but the point is you understand, yeah? You understand?
Yes.
Okay, good job. Let's for today. You can do something if you want. Bye bye. What you doing? Okay, show it to people. Come on, one more time.
Hey! Ow!
Okay, that's it for today.